stream. So next one is innovative smart city initiatives for, I have, so we have here Mr. P.R. Nair, who's representing Mr. Nandakumar, who's the Chairman Managing Director for Chemtrol's Industries Limited. He's going to talk about waste to wealth, multimodal usage of biogas as green urban future. Is that accurate? Yes.
P.R. Nair, I am representing Mr. Nandakumar, who is our CMD. He is away on account of some other urgent work. Waste to wealth, multimodal usage of biogas as green urban future. It is estimated on an average 3 kg of waste is generated per person every day. When extrapolated, this is India's this to the India's population, the quantum of organic waste even after separation from non-biodegradable naturally distributed across the population is very huge. As urbanization is moving at a faster pace, it is estimated that 2/3 of Indian population will migrate to urban areas by 2050s. Thus, the potential of biogas generation in urban areas goes up fourfold. Newer technologies are developed to produce high purity biogas within shorter time cycle, even in small volumes, and hence the usage of biogas gets extended to cooking, heating, or lighting indoors, reducing pollution and for vehicular movement outdoors, apart from grid-connected electricity generation. This presentation throws light on various emerging opportunities. In the economic scenario 2014 to 2020, the population is going to increase from 1.2 billion to 1.6 billion by 2020. The urban population is increasing from 31 to 40%. Due to the urbanization of Indian cities, the society's transformation from predominantly rural to predominantly urban population. Urban settlement is defined as human settlement with population density of 400 persons per square kilometer, with minimum population of 5,000 persons in a defined area, with 75% of male working population in non-agricultural sector. India urbanization, by 2030, half of Indian population is expected to migrate to urban cities. By 2060s, 2/3 of Indian population is expected to settle down in urban cities. The main challenges in the urbanization are providing infrastructure at affordable cost, housing, roads and transportation, drinking water and sanitation, distribution outlets, managing waste generated by municipal solid waste, liquid waste, sewage, recycling, etc., meeting the energy needs, grid connected as well as distributed. These are the solid waste which we'll have to manage. And the biogas is the methane it is methane rich flammable gas that results from decomposition of organic waste material under anaerobic conditions. This is a byproduct of cleaning up of wastewater. Typical biogas composition could be about 30 to 40% CO2, 50 to 60% CH4, 1 to 2% H2S, and traces of H2, etc. This biogas could be converted to produce heat or power based on end users' requirement and the amount of waste generation. The requirements are organic waste, household farm waste, sewage, wood pulp, etc., a fermenter, digester, inoculated with select bacteria, methogens, and decomposers under anaerobic conditions with optimum minimum temperature of 35 to 38 degrees centigrade, optimum pH of 6.5 to 8. These needs to be monitored as decomposers produce acids that can work faster than the methanogens consume the acids. The biogas comes from vegetation, farm and ranch animals, sewage, landfills. Garbage produces methane as it decomposes. Sweet gas, methane without H2S, naturally produced at coal beds, contains very little heavy heavier hydrocarbons. The amount of methane stored beneath the Arctic is calculated to be greater than the total amount of carbon locked up in global coal reserves. The chemistry of generation of biogas is shown in this slide. Uh, the biogas power plant process outline is also shown in this slide. The ETP or STP sludge is taken into the sludge collection tank, as well as the waste from farm and other places are also collected there. And from the sludge collection tank, the sludge transferred into the digester, and from the digester we get the biogas, which generally gets flared, and we can use it as a for running an engine and generate power, or even we can use it and compress it and use it for auto gas. Biogas as a replacement for LPG. This is with from the household waste, hotel waste, etc. You can collect homogenization of liquid biomass, transfer pump to the biogas digester. There is a manual collection from the digester bottom, and biogas directly can be used for the biogas burner. The benefits of using the biogas are it is renewable and easily obtainable, cost effective, environment and neighborhood friendly, reduction of green gas emissions through methane recovery, on-site farm energy, reduced odor, high quality fertilizer, reduced surface groundwater contamination, and pathogen reduction. In summary, the waste can generate thermal energy from the biogas, transport fuel also from the biogas, electricity and energy from the biogas, and environmental flaring from the biogas, and fertilizer. So why make biogas? It is always cost money to get rid of waste. So if it doesn't cost anything, you are probably creating an environmental hazard. By putting digester in your waste treatment chain, you introduce a potential revenue center. For example, on a farm, the manure is considered to be the waste, but fertilizer is not considered to be a waste, but a fertilizer. By installing a digester, the farmer can profit from the biogas by reducing the odors and enhancing the fertilizer value. A few questions about the biogas. How much energy is in a biogas? 1 meter cube of biogas generates 6 kilowatt of gross energy. How long does it take to build a biogas plant? For a moderate to high capacity, that is 4 tons, it takes only 12 to 14 months. For smaller family size digester, 2 to 3 months. What happens to the waste after digestion? Waste separation to solid and liquid. Solid is decomposed, liquid is sent as liquid fertilizer or treated. The methane matters. The methane's global warming potential is 21 times higher than CO2 in warming the earth. It stays in the atmosphere for about 12 years. Methane in atmosphere has been increasing at a rate of 1% per year during the past 15 years. So what are we waiting for? So this model is essential for any smart city or even a urban city, and we are operating about 3 plants in Gujarat and in Rajasthan on a O&M basis as on today. These plants were built up by us only. Any questions?
So what is the smallest, in terms of housing units,
Yeah.
number that is required to install a biogas plant in terms of number of housing if we take? Can it be done on a private level or
Private-
should it be a city level?
No, private level also many companies are providing the biogas.
Smallest
It-
number
it-
of houses, let us say, if we take a community of housing.
Those full details I may not be able to know, but there are capacities like 500 kg to 200 kg capacity biogas generators. Uh, No, no, that may be a higher capacity, because nowadays a lot of smaller capacity biogas generators are also available, which is available in the market. Smaller capacity, you can have it in housing societies, even houses also they can have biogas generation. It is small quantity. That is also available in the market. I will have to check up, but it is available as far as I know, smaller capacities. No, I have to check up because we also source it out. We don't do this. Yeah, these are available in the market.
I think we are at end of time.
Yeah.
Thank you, Mr. Nair,
Welcome.
for the presentation of the biogas. I think some questions. I think in my experience, I've seen one place they had about 150 houses and they had a biogas plant. It wasn't very large. It was maybe 4 meters across. And so I've seen as small as that. So really, my understanding is it's a matter of the size.
It is only a question of putting a electricity generation. Then there are limitations. You have minimum capacity is 0.5 megawatt. That is a minimum capacity of the biogas generator. Rather. I mean power generator. Yeah. Thank you.
Thank you so much.
Yeah.
Thank you for that.